Here we have limit x tends to 0, x cube cot x upon 1 minus cos x. So whenever we have 1 minus cos x, we have to multiply its conjugate, which is 1 plus cos x. So limit x tends to 0, x cube cot x and 1 plus cos x will be as it is. And in denominator, we have a minus b and a plus b, which is converted into a square minus b square. So we'll get 1 minus cos square x. And we can convert this cot x into cos x upon sin x. So we can say 1 minus cos square x is sin square x, and this sin x will combinedly become sin cube x. So cos x into 1 plus cos x will remain as it is. Now, if we take this cube common, we will get sin x upon x. So if we apply the limit, your sin x by x will become 1. Here we'll get cos 0 and 1 plus cos 0. And we know that cos 0 is 1. So your final answer will be 2, which is given in option C. Ta-da! In this question, we have to solve limit x tends to 1 log x upon x minus 1. Now, here we have logarithmic functions, so we have to convert into this standard form. And for that, let's change your limit. If x tends to 1, we can say x minus 1 will tends to 0. Similarly, within the log, we need 1 plus your function, which is x minus 1. So we can say here we are add and removing minus 1. And we already have x minus 1 in the denominator. So for further simplification, let's assume x minus 1 is equal to t. So your limit will become limit t tends to 0 log 1 plus t, and we have t in the denominator, which is in the standard form. So your answer must be 1, which is given in option A. Ta-da! In this question, we have to solve limit x tends to 0, x into log sin x. If we try to check the form of the equation, we have 0 into infinite form. So to solve this kind of a formula, we have to convert into the infinite upon infinite form. So we can say your log sin x will be as it is, and we will shift this x into the denominator as 1 by x. So we'll get infinite by infinite form, and we can apply L'Hospital rule. So the differentiation of log sin x, we have to consider sin x within the box. So differentiation of log box will be 1 upon box into differentiation of box. Now, within the box, we have sin x. So differentiation of sin x will be cos x. Similarly, differentiation of 1 by x will be minus 1 upon x square. Now, let's try to simplify. Limit x tends to 0. This x square will move into the numerator. Let's say it is x into x, and sin x is in denominator. So here we get sin x upon x, and we are ready to apply the limit. Your x will become 0, sin x by x will be 1, and here we'll get cos 0, which is also 1, but 0 into anything is 0. So option B is your answer. Ta-da! In this question, we have limit x tends to 0, cosec x raised to 1 upon log x. So let's check the form. Cosec 0 is infinite and log 0 is also infinite. So infinite raised to 0. To solve this kind of a question, we have to assume question is equal to y and take log on both sides. So here we'll get limit x tends to 0, log cosec x, and this raised to 1 upon log x can be moved to the multiplication of log. So here we'll get log cosec x upon log x. Now we know that this is your infinite upon infinite form. So we can apply L'Hospital rule. So to differentiate log cosec x, we have to consider cosec x within the box. So differentiation of log box will be 1 upon box into differentiation of box. And we know that within the box we have cosec x. So differentiation of cosec x is minus cosec x into cot x upon, now we have to differentiate log x, which is simply 1 by x. Now let's simplify. This cosec x will cancel out. We can say cot x can be rewritten as 1 upon tan x, and 1 upon x will move to the numerator. So here we'll get x upon tan x minus 1, which is equal to log y. So we can say y is simply e raised to minus 1, or we can say 1 by e is our final answer, which is given in option C. Ta-da! In this question, we have limit x tends to 1, tan x square minus 1 upon x minus 1. Now, this is the question of trigonometry. So, we need tan theta upon theta. So, to get x square minus 1 within the denominator, let's multiply and divide by x plus 1. If limit x tends to 1, we can say x square minus 1 will tends to 0. So, we'll get tan x square minus 1 upon this x minus 1 into x plus 1 will become x square minus 1, and your x plus 1 will remain as it is. So we can say your theta is tends to 0, and we have tan theta upon theta form. So its answer will be 1. And here we have to replace your x by 1. So we get 1 plus 1. So the final answer will be 2, which is in option A. Ta-da! In this question, we have limit x tends to a, x plus 2 raised to 5 by 3 minus a plus 2 raised to 5 by 3 upon x minus a. Here we have polynomial type sum. So we will try to apply the formula of polynomial. Now, we have x plus 2 raised to 5 by 3 minus a plus 2 raised to 5 by 3. So we need x plus 2 and a plus 2 over here, as well as your x plus 2 should be tends to a plus 2. So let's change whatever is required. Your x tends to a, so we can say x plus 2 will also tends to a plus 2. Your numerator will be as it is, and in denominator we can add and remove 2. So we'll get x plus 2 minus a plus 2. So we get into the standard form where your x is x plus 2, a is a plus 2, and n is 5 by 3. So your answer must be n into a raised to n minus 1, or we can say 5 by 3 into a plus 2 raised to 5 by 3 minus 1, or we can say 2 by 3, which is given in option A. Ta-da! Here we have limit n tends to infinity 1 plus 2 plus 3 up to n upon n square plus 100. બધામાં છે ને x tends to finite છે, ક્યાં infinite નહીં દેખાય, આપણા ક્વેશ્ચનમાં જ infinite છે. Whenever we have n tends to infinity or some term tends to infinity, try to get that term into the denominator. So we can say 1 upon n will tends to 0. So try to get your n into the denominator. So for that, we have to simplify the terms. Your numerator is summation of n terms, which is nothing but n into n plus 1 by 2. And your denominator will be as it is. Now, we need to get n into the denominator. So we can say divide numerator as well as denominator by maximum power of n, which is n square in this case. So your numerator will become 1 power of n will cancel out and we'll get n plus 1 upon n, or we can say 1 plus 1 upon n. Similarly, in denominator, we'll have n square plus 100 upon n square, or we can say we will have 1 plus 100 upon n square. So we can say if n tends to infinity, 1 upon n will tends to 0. Apply the limit, we will get 1 plus 0 upon 2 times 1 plus 0. Or we can say your final answer will be 1 by 2, which is in option B. Ta-da! In this question, we have limit n tends to infinity 1 upon n square plus 2 upon n square plus 3 upon n square up to n upon n square. Or we can say if we take a LCM of n square, we will get n square in the denominator and your numerator will be 1 plus 2 plus 3 up to n. Now, first of all, we have to simplify. In numerator, we have summation of n terms, which is nothing but n into n plus 1 by 2 upon n square. So your 1 power of n will cancel out, and if we give individual denominator to n plus 1, we'll get 1 plus 1 by n. Your 1 by 2 will be as it is. Now we know that if n tends to infinity, 1 upon n will tends to 0. So here we'll get 1 by 2 into 1 plus 0, or we can say 1 by 2 is your final answer, which is given in option A. Ta-da! In this question, we have limit n tends to infinity, summation of n square upon n cube. So we can say summation of n square is simply n into n plus 1 into 2n plus 1 by 6, and your n cube will be as it is. Here we have to give individual n to the all brackets. This n will cancel out, so we'll get only 2 power. Now, one n is go with the n plus 1 and another n will go with 2n plus 1. So here your 1 by 6 will be as it is. N plus 1 upon n can be rewritten as 1 plus 1 by n, and 2n plus 1 upon n is simply 2 plus 1 by n. And we know that if n tends to infinity, 1 upon n will tends to 0. So your answer will be 1 by 6, 1 plus 0, and 2 plus 0. Or we can say 1 by 3, which is given in option C. Ta-da! In this question, we have f of a as 2, f dash a as 1, g of a minus 1, and g dash a is equal to 2. And we have to find the limit x tends to a, g of x f of a minus g of a f of x upon x minus a. Here we have to use the formula of derivative. F dash a is equal to limit x tends to a, f of x minus f of a upon x minus a. Similarly, we can say g dash a is equal to limit x tends to a, g of x minus g of a upon x minus a. Here, to simplify this, in numerator, we have to add and remove the constant term, which is nothing but g of a and f of a. And rest of the terms will be as it is. Now, here, from first two terms, we can take f of a common. So remaining terms will be g of x minus g of a. From the rest of the two terms, we should take minus g of a common. So you will get f of x minus f of a and give individual denominator x minus a and x minus a. So if we apply the limit, we will get f of a into g dash a minus g of a into f dash a. Now place the value. Your f of a is 2, g dash a is also 2. Then g of a is minus 1 and f dash a is plus 1. So here we'll get 4 plus 1, or we can say 5 as your answer, which is given in option B. Now, let's try to solve same question with the help of L hospital. Okay, if we place the limit, we'll get 0 by 0 form. So we can apply L hospital rule. So differentiation of g of x will be g dash x, your f of a, and g of a will be as it is because it is a constant term, and differentiation of f of x will be f dash x upon differentiation of x will be 1, differentiation of a will be 0. So we are ready to apply the limit. Replace your x by a. So here we'll get g dash a f of a minus g of a into f dash a. And now just place the values. G dash a is 2, f of a is also 2, g of a is minus 1, and f dash a is 1. So we'll get 5 as your answer. Ta-da! In this question, we have limit n tends to infinity 1 cube plus 2 cube plus 3 cube up to n cube upon n raised to 4. So here in numerator, we have summation of n cube, n square into n plus 1 the whole square upon 4, and your n raised to 4 will be as it is. Now let's simplify. 2 power of n will reduce, so we'll get n square. So here we'll have n plus 1 upon n the whole square, or we can say we'll have 1 plus 1 by n the whole square. So if we apply the limit, we'll get 1 by 4, 1 plus 0 the whole square, which will give us 1 by 4, which is in option C. Ta-da! In this question, we have limit x tends to a cos x minus cos a upon cot x minus cot a. If we apply the limit, we will get 0 by 0 form. So let's apply L'Hospital rule. Differentiation of cos x is simply minus sin x. Differentiation of cos a is 0 because it's a constant term. Similarly, in denominator, differentiation of cot x is minus cos x square x, and differentiation of cot a is 0. Now, this minus minus become plus, sin x will be as it is, and cos x square x is nothing but reciprocal of sin x. So we'll get sin square x. So this will become sin cube, and if you replace your x by a, we'll get sin cube a, which is in option C. Ta-da! In this question, we have limit x tends to 0 log a plus x minus log a upon x plus k times limit x tends to e log x minus 1 upon x minus e is equal to 1. Now, first of all, let's try to solve this question using definition of derivatives. In first term, we have x tends to 0 log a plus x minus log a upon x. So if we compare with the first form, it is equal to f dash a, where your f of x is nothing but log x. Now, in second term, we have limit x tends to e log x minus 1, or we can say log e upon x minus e. जो तो second form जोड़े compare करो. This is your f of x, f of a upon x minus a. This is your f of x, f of a upon x minus a. So we'll get Again, f dash e, where f of x is log x. So your question can be converted into f dash a plus k into f dash e is equal to 1. Now, we already know that your fx is log x. So f dash x must be 1 by x. Or we can say f dash a is 1 upon a and f dash e is 1 upon e. So 1 by a move to the right side, we'll get k into 1 by e is equal to 1 minus 1 by a. Or we can say your k must be e into 1 minus 1 by a as your answer, which is given in option A. Now, let's try to solve the same question using L'Hospital rule. Now, your first limit is in the form of 0 by 0. So we can apply L'Hospital rule. So we'll get limit x tends to 0. Differentiation of log a plus x will be 1 upon a plus x minus differentiation of log a is 0 upon differentiation of x will be 1. Now, let's move to the second term, which is also in the form of 0 by 0. So we can apply L'Hospital rule. Limit x tends to e, differentiation of log x is nothing but 1 by x minus differentiation of 1 will be 0 upon differentiation of x minus e will be 1 minus 0 is equal to 1. Now, we are ready to apply the limit. We have to replace your x by 0. So here we'll get 1 by a. Then in second term, we have to replace your x by e. So we'll get 1 by e is equal to 1. So we can say k times 1 by e is 1 minus 1 by a. So finally, we'll get k is equal to e times 1 minus 1 by a as your answer, which is given in option A. Ta-da! So both method will give us same answer. In this question, we have limit x tends to 0, e raised to alpha x minus e raised to beta x upon x. Now, first of all, let's try to solve this question using this formula. So, we have e raised to alpha x and we need minus 1. So, let's add and remove 1. So, we'll get e raised to alpha x minus 1. And if we take minus common, we'll get e raised to beta x minus 1 and give individual denominator. But still, we have to change your limit also. Whenever we have alpha x, we need alpha x in the denominator as well as your that term must be tends to 0. So x tends to alpha x is also tends to 0. E raised to alpha x minus 1 and let's multiply and divide by alpha. Now we have to do the same thing with the second term. If x tends to 0, beta x will also tends to 0. We have e raised to beta x minus 1 and let's multiply and divide by beta. So we are ready to apply the limit. Alpha x tends to 0, e raised to alpha x minus 1 upon alpha x will become 1 into alpha and second term will become 1 into beta. So your answer will be alpha minus beta, which is given in option D. Now let's try to solve the same question with L'Hospital rule. Here, your question in the form of 0 by 0. So let's differentiate numerator as well as denominator. Differentiation of e raised to alpha x will be e raised to alpha x into alpha minus differentiation of e raised to beta x will be e raised to beta x into beta upon differentiation of x will be 1. Now we are ready to place the limit. We'll get e raised to 0 into alpha minus e raised to 0 into beta, or we can say alpha minus beta is your answer. Ta-da! In this question, we have limit n tends to infinity 3 into 2 raised to n plus 1 upon 5 into 2 raised to n plus 7 into 5 raised to n. Here we have exponential type sum. We have 2 raised to n as well as 5 raised to n. So, first of all, let's try to simplify our numerator. This 2 raised to n plus 1 will split into 2 raised to n into 2. So, If we multiply 3 and 2, we'll get 6. Similarly, in second term, we'll get 4 into 5, or we can say 20 into 5 raised to n. And your denominator will be as it is. Now, we have two terms, 2 raised to n and 5 raised to n. Divide whole question by bigger number. In this case, it is 5 raised to n. So, we will divide numerator as well as denominator by 5 raised to n. So, we'll get 6 into 2 by 5 raised to n minus 20 into 5 raised to n. 5 raised to n will cancel out. Similarly, divide denominator by 5 raised to n. So, we'll get 5 into 2 by 5 raised to n plus 7 into 5 raised to n. 5 raised to n will cancel out. Now, if we apply the limit, we know that 2 by 5 is less than 1. So, 2 by 5 raised to n will tends to 0. So, we'll get 6 into 0 minus 20 upon 5 into 0 plus 7, or we can say minus 20 by 7 is your final answer, which is given in option A. Ta-da! In this question, we have limit x tends to infinity 1 plus 1 by x raised to x. So, to apply the formula, here we have mx. So, we need mx in the power also. So, let's multiply and divide m in the power. So, it will become x into m and divided by m. So, your bracket will become e and we'll get e raised to 1 by m, which is given in option A. Ta-da! We have limit x tends to 1, 1 plus log x minus x upon 1 minus 2x plus x square, 0 by 0 form. So we can apply L'Hospital rule. So we can differentiate your numerator and denominator individually. Differentiation of 1 plus log x minus x will be 0 plus 1 by x minus 1 upon, now we'll differentiate denominator. So it will be 0 minus 2 plus 2x. Again, we'll get 0 by 0 form. So we can differentiate numerator and denominator individually. Differentiation of 1 by x will be minus 1 upon x square minus 0 upon 0 plus 2. So finally, we can apply the limit and we'll get minus 1 upon 1 square upon 2. Or we can say minus 1 by 2 is your answer, which is given in option D. Ta-da! In this question, we have limit x tends to 0 cot 4x upon cosec 3x. So first of all, let's try to simplify. Your cot is simply reciprocal of tan and cosec x is simply reciprocal of sine. So we have to apply the formula of trigonometry. So we are going to need 4x. So multiply and divide by 4x as well as 3x. So let's multiply and divide by 3x. So your xx will cancel out. We'll get tan theta by theta as well as sine theta by theta form. Here, your x is tends to 0. So we can say 4x will also tends to 0 and 3x will also tends to 0. So we'll get 1 into 1 into 3 by 4. Or we can say 3 by 4 is your final answer, which is given in option B. Ta-da! In this question, we have to find value of limit n tends to infinity nc3 minus np3 upon n cube. Now, first of all, let's simplify nc3, which is nothing but n factorial upon n minus 3 factorial into 3 factorial. Similarly, np3 is n factorial upon n minus 3 factorial. So, from these two terms, we can take n factorial and n minus 3 factorial common. So remaining terms will be 1 upon 3 factorial minus 1 upon 1. Now we know that n factorial can be simplified as n into n minus 1 into n minus 2 into n minus 3 factorial upon n minus 3 factorial. And 3 factorial is nothing but 6. So if we take LCM, we'll get 1 minus 6 upon 6. So n minus 3 factorial will cancel out and we'll get n into n minus 1 into n minus 2. And your bracket will be minus 5 by 6. So we are ready to find your limit. Limit n tends to infinity. Your numerator is minus 5n n minus 1 into n minus 2 upon 6. And we have n cube. So here 1 power of n will cancel out. So you'll get n square. And we know that whenever your n tends to infinity, we have to give individual n. One n with n minus 1 and another n with n minus 2. So limit n tends to infinity minus 5 by 6 and n minus 1 upon n will be 1 minus 1 upon n. Similarly, 1 minus 2 upon n. So we are ready to apply the limit. We'll get minus 5 by 6, 1 minus 0 and 1 minus 0. So final answer will be minus 5 by 6, which is given in option A. Ta-da!